In this part of the data structure course related to dynamic memory, you will learn memory allocation operations, new and delete. Through an example class called dynamic class, which has dynamic data member beside its static data member, you will learn how to implement constructor. We will examine why it is necessary to implement a destructor method for the class and also to overload the assignment operator when a class has dynamic part. Memory allocation operator new is used to create objects dynamically. In this line, there is a declaration of P as a pointer of type T. Here, by the new operation, an object of type T is created. Memory is reserved for that object, and the address of that memory is stored into pointer P. Consider these examples. We have ptr1, which is a pointer to an integer. Size of int is 2, assume that. And ptr2 is a pointer to long integer. Size of long is 4. Here we have new operation, new int, and the address is loaded to ptr1. So 2 bytes memory is reserved for this object, and the address is loaded to ptr1. So ptr1 is the pointer pointing to this object which has no name. And in this line there is a new long operation, and the address is loaded to ptr2. ptr2 is a pointer to a long integer. So in that case, 4 bytes are reserved for the new object and its address is loaded to ptr2. Here, by the new operation, 4 bytes are reserved in memory and the address of this object is stored to ptr2. Again, the object has no name. By default, the content in memory have no initial value. If such a value is desired, it must be supplied as a parameter when the operator is used. Here we have new operation and we have of type T and the value is provided here and the address is loaded into P. New long integer, the value is this one and the address is loaded into ptr2. Also, array can be allocated dynamically. We are saying that new T having n elements and the starting address is loaded to P. Allocate an array of n items of type T. Here are some examples. Long pointer P, P assigned value, the address of array of long integer having 50 elements, and that address is loaded to P. This line is to allocate an array of 50 long integers. After that allocation, we can check if there is enough memory. If P is null, then it means that there is a memory allocation error. We can send to the error device this message and end line. After that, we can terminate the program. If this is not null, that means that memory is allocated successfully and the address is in the pointer P. In this part, we are going to consider memory deallocation operator delete. P and Q are 2 pointers of type T. By this new operation on T, the address of a single item is loaded to pointer P. So P points to a single item. In this line, we have a new operation to allocate memory for an array. Array is of type T and memory is reserved for n items and the beginning address is loaded to Q. So Q points to an array of elements. After memory is allocated, we can apply some operations on the items pointed by P and Q. And then when we are not to use those items anymore, we can remove them from memory. Delete P operation deallocates the object pointed by P. Delete array Q deallocates the entire array pointed by Q. Here there is an example to show how the dynamic memory is used in classes. We are defining a template class whose name is dynamic class. In the private part, we have two data members. Member 1 is of type T, this is a template type, and member 2 is a pointer to an object of type T. This is the dynamic class. We have member 1 and member 2, which are the static data of the dynamic class. And this part is to be created dynamically, whose address is going to be stored in member 2. In the public part, we have constructor with parameters to initialize member data. This is the constructor having the same name with the class. We have two parameters to initialize member data. We have M1 and M2. M1 is going to be stored in member 1, and M2 is to be stored in this dynamical part whose address is in member 2. These are declared as references to type T, and they are constant. We have copy constructor in addition to the constructor given here. This is to create a copy of the input object. When the copy constructor is called, an object is created whose initial data is same as the one stored in the obj. And notice that this argument obj is of type dynamic class of T, and this is a reference and it's a constant. There may be some other methods. Additionally, we have assignment operator. This is to overload the assignment operation. In this one, we have a parameter which is called RHS, right-hand side. It is of type dynamic class, and it is constant and reference. And this object is going to be assigned as the value of the object in the left-hand side. Here, the assignment operator is shown as operator and equal sign. It will return an object of type dynamic class T. And additionally, we have a method which is called destructor of the dynamic class. No input is needed. Notice that it has the same name as the class, and here this tilde is showing that it is not constructor but destructor. Now we are going to implement the dynamic class. First, we are considering the constructor with parameters to initialize member data. It is going to be implemented as a template function. The name of the function is dynamic class. It is the constructor. We have parameters M1 and M2. They are of type T and they are reference and constant. This is a function belonging to the dynamic class. We are setting member 1 to M1 given here. For the member 2, by using a new operation, an object of type T, this is a template type, is created for which the value is initialized to M2. For member 2, an object of type T is created by new operation and it is initialized to M2, which is the parameter given here. And then there is an output statement. This is indicating that the constructor is called. The value of member 1 is this one, slash, and the value of the item pointed by member 2 is this one, and end line. Here is the class implementation. First, we are starting with the constructor with parameters to initialize member data. It is going to be implemented as a template class. The name of the function is dynamic class. It is same as the class itself because this is the constructor. This is belonging to the class dynamic class of type T. Here we have two parameters, m1 and m2, which are of type T, and they are references and constant. Parameter m1 initializes static member. Member 1 is assigned value m1. And also allocate dynamic memory and initialize it with value m2. By new operation, an object of type T is created. It is initialized with value m2, and the address of the object just created is loaded into member 2. Then we have an output statement saying that the constructor is called. The value of the member 1 is this one. It is going to be outputted slash the value of the object pointed by member 2 is outputted, and then we have end line, and this is the end of the constructor with parameters to initialize member data. As an example, consider the following declarations. The following statements define a static variable, static obj. The static obj has parameters 1 and 100 that initialize the data members. So here there is a declaration. Static obj is declared here. It is of dynamic class integer, and here we have 1 and 100, which are integer values. When this is executed, static obj is created, and for this one, the value for the member 1 is 1, and also an integer is created by the new operation in the constructor. Here constructor is called, and the address of this object is stored in the member 2. So this is pointing to object having value 100. In the following, the object dynamic obj is created by the new operator. Parameters 2 and 200 are supplied as parameters to the constructor. First, we are declaring a pointer variable, dynamic class, integer, pointer, dynamic obj. Dynamic obj is a pointer to an object of type dynamic class int, and then an object of dynamic class integer is created by the new operation, and the values provided are 2 and 200. So here an object is created, 2 is stored here, and also by the new operation in the constructor, an object having value 200 is created, and its address is loaded into member 2. And this is the dynamic class object of integer type, and the address of this object is loaded into the pointer dynamic obj, because we have a new operation here. An object of dynamic class integer is created, and its address is loaded into dynamic obj. Running the program results in, first, here there is a call to the constructor with parameters 1 and 100. So we will see this line at the output. For the second declaration, again the constructor is called here with parameters 2 and 200. Again, we will see constructor 2/200 at the output. For the deallocation object data, the destructor is used. Consider the function destroyDemo that creates a dynamic class object having integer data. The name of the function is destroyDemo with parameters m1 and m2, which are integers. There is no return value. Inside the function, an object named obj is declared. It is of type dynamic class integer. We have parameters m1 and m2 for the constructor, which are the values provided here. Here the function starts, and this is the end of the function. Upon return from destroyDemo, obj is destroyed, However, the process does not deallocate the dynamic memory associated with the object. Whenever there is a return from a function, whatever declared, whatever created within the function is removed from the memory. But here, because we have a dynamic part in which M2 is stored, it will not be removed from the memory because it is created dynamically. So the system memory before obj destroyed is like this. We have M1 stored here and we have pointer value pointing to an integer having value M2 in this example. This is the object in the memory. In fact, we would like this object to be removed from the memory upon return from the function. However, it happens the static part removed from the memory, but the dynamic part created by the new operation remains in the memory. For effective memory management, we need to deallocate dynamic data within the object at the same time the object being destroyed. The C++ language provides a member function called the destructor, which is called automatically when the object is destroyed. For dynamic class, the destructor has the declaration tilde dynamic class void. The character tilde represents complement. So tilde dynamic class is the complement of the constructor dynamic class. A destructor never has a parameter or a return type. For our sample class, the destructor is responsible to deallocate the dynamic data for member 2. The destructor deallocates memory allocated by the constructor. It is implemented as a template method, and here the template class is T. Dynamic class destructor is a method for the dynamic class of type T. There is no parameter. First, we are outputting the word destructor to indicate that this function is called, and then member 1 and member 2 are sent to output device, and then we have a line feed, and then we have delete member 2 in the destructor. This is the dynamic part created by the new operation in the constructor, so we have to delete it in the destructor. However, the static part of the data removed from the memory automatically. The destructor is called whenever an object is deleted. When a program terminates, all global objects or objects declared in the main program are destroyed. For local objects created within a block, the destructor is called when the program exits the block. As an example, consider the function called destroy demo. We have parameters m1 and m2, which are integers. There is no return value from the function. Inside the function, only there is a declaration of the object of type dynamic class integer. Here, for the constructor, m1 and m2 are used as parameters, which are the parameters of the destroy demo itself. That's all for the function destroy demo. In the main part, we have declaration of obj1 with parameters 1 and 100, and obj1 is type of dynamic class integer, and also obj2 is declared as a pointer to dynamic class integer object. This one is a static object having dynamic parts. Here, the second object is created by the new operation with a call to the dynamic class constructor with parameters 2 and 200. And it is created by the new operation. The address of the object is loaded in obj2, which is a pointer to dynamic class integer object. And then destroy demo is called with parameters 3 and 300. And then we have delete obj2, and this is the end of the main part. Now let's try to understand what is the output by running the program. It results in the output. Let's start with the main part. Here there is a declaration of obj1. So here there is a call to the constructor. Constructor is called by 1 and 100 here. And then here there is another call to the constructor due to new operation. This time the parameters are 2 and 200. This is member 1 and this is member 2. So at the output we see constructor to 200. Then there is a call to the destroy demo. Here 3 and 300 are the parameters sent here. Inside the destroy demo, we have declaration of obj, and this is a call to the constructor of the dynamic class. The parameters were 3 and 300, so we will see the line saying constructor 3/300. Then we are at the end of the function destroy demo. So whatever declared within the function will be removed from the memory. Here there is a call to the destructor for obj. So we will see destructor 3 and 300 because the parameter values for member 1 and member 2 were M1 and M2. Here we will see destructor 300 because the object created here with parameters 3 and 300 will be destructed at this point with a call by the end of the destroy demo. This is the end of the function destroy demo. When it is to return from the function, whatever declared within the function is destroyed. Here we have obj as a dynamic class object. Because of that, the destructor belonging to the class is called. Because the value member 1 and the object pointed by member 2 are 3 and 300, the destructor is called, and at the output we will see destructor 3 and 300 here. And we return back to the point just after destroy demo here. It returns from the function. Here there is delete operation on obj2. So this is a call to the destructor for obj2. Here notice that an object of dynamic class were created by using new operation and its address were in the obj2. Before returning from the main program, whatever declared as a dynamic object with the new operation should be deleted within the program. Because of that, we have delete obj2 here. By this delete operation, the destructor is called and the members are 2 and 200 for that object. And by the end of the main part, by this curly parenthesis, whatever declared inside the main program is deleted from memory. Here we have obj1, which is declared as a dynamic class object. The destructor will be called for obj1 because the members are 1 and 100 here. We will see at the output destructor 1/100.